So before we actually dive into writing some NGRX store and effects code, we're going to actually take a look at what is NGRX store on a higher level. Now we've already looked at the Redux pattern, which is essentially what NGRX store is built upon. But essentially, you can think of NGRX store as a Redux-inspired reactive state management library. Now there's quite a few words in there. We have reactive, we have state management. So what do these kind of mean on their own? We obviously have Redux, where we've covered those principles in the earlier chapters, and we also have the word reactive. Now, when we think in terms of observables, observables give us that reactive paradigm where we can react to new data flow changes or events in an observable stream. So essentially, NGRX store allows us to have some kind of observable driven state management library alongside our Angular code. So let's have a look at some of the characteristics of the NGRX store module. So we know already that it's based on Redux. We've just mentioned that it's written with observables, so you can actually take a dive through the source code and actually see how it differs from our plain TypeScript implementation, where we wrote our own custom Redux store. More specifically, NGRX store is built for Angular. It's made for Angular. That's what the NG and the RX actually mean. So NG is Angular and RX means reactive. So that's where we have the reactive store package. We've got the reactive effects package. We've also got the router store package, which we're going to include in this course as well. So before we even kind of dive into let's just use NGRX, let's actually just take a step back and understand some of the benefits we get when we want to use something like NGRX store. So we get that benefit of the single source of truth. So the whole state of our application is contained and represented in a single state tree. We also get the benefit of testing. Most of the things with NGRX store are just pure functions. We have selectors, which are just pure functions. We have reducers, which are just pure functions. And we also have actions, which are just plain constants or classes. Now, all of these are actually really easy to test. And at the end of this course, we're going to learn how to test some of the things that we've been working with, the actions, the reducers. We're also going to test the effects and the selectors. So let's talk a little bit about change detection and the performance benefits that we get from using a single store, or rather an observable approach to managing state in our applications. Now, a component doesn't really care where it gets its data from. By default, Angular has a built-in change detection strategy which uses the default. So it's trying to look in your component and it uses something called a zone to be able to detect whether it needs to update or not. Now we can actually use this on-push change detection strategy to tell Angular that our inputs, which is our @input decorator, will be 100% immutable. Now because of the patterns that we use with a single store, we have our reducers which return pieces of new state. These new state are composed in an immutable way, and we just simply use a selector to select a piece of state. So whenever that changes, we get given it back to our container components, which are then passed down into stateless, or you could call it a presentational component. So the beauty of using the on-push change detection strategy means that we're actually comparing objects rather than checking properties and values. So when we use our on-push change detection strategy, we're essentially telling Angular to compare the references of objects rather than try and work out what's changed within inside an object. No two objects are the same unless it's the same object. So essentially what will happen when we mutate some of our data and pass it back to the store, this in effect will give us a brand new object. So Angular can say, does this object equal this object? Yes or no? If it's yes, then clearly something hasn't changed and nothing will happen further down in that component. However, if something has changed, those objects won't actually equal each other. They won't be of the same object identity. So this means Angular can just essentially ignore all of its change detection, and we can just use observables to push new changes down the component tree. We also get the root and feature module support. So we've got eagerly and we've got lazily loaded modules. Now in the application, we're going to have a lazy loaded module, and we'll use a for feature call on our store module, which indicates to NGRX store that we have either an eagerly or a lazy loaded module. Now NGRX will support both of these out of the box with the latest version that we're using in this course. So we're going to take full advantage of using lazily loaded modules, and NGRX store behind the scenes, when we load in an Angular module, will then bind itself to the parent store module, which we can call the root module. So that's just a nice overview of what we're going to be diving into in the rest of this course. So let's go ahead and get started.